We have an interesting project here today. We have a multiplayer game engine that someone made that runs in both a client-server architecture as well as a peer-to-peer architecture. I'm going to take it a little bit further than I do with normal code reviews. I'm actually going to try this out in a real environment and we're going to see if it holds up. Because a lot of these projects that people send me are usually quite good within like the small scale that they've been created in. However, if they were to exist in the real world, then unfortunately they tend to fall apart. Will the project that we're going to look at today suffer the same fate? Let's find out. Hi Cherno, I'm Joshua, currently pursuing a master's in computer science. Last fall, my friends and I developed a 2D multiplayer game engine using SDL2 and ZeroMQ as part of a university assignment. This is like a networking library. Below are the screen grabs from all the games built with this engine, so you can see there's a whole bunch of example games, which is really cool. Here's a link to the GitHub repository. While it's fine if our names appear on the video, since this is a university assignment, can we please keep the link to the repository anonymous? We can, however, it is public on GitHub, so but sure, we'll respect that and not provide the link. P.S. Thank you for your content. I really appreciate the code review series. They've been a fun way to learn from your experience. With regards, Joshua Joseph. So what we have in front of us is a multiplayer game engine that's capable of running all of these different games. Let's go ahead and start with maybe the homebound one, and we'll try and get that up and running. Okay, so here we are in Visual Studio building in release. I'm already noticing how many of the same file are being built again and again for different projects. I just did a build all, so it's actually building all of the projects, and it looks like immediately what I'm noticing is that every single game here actually includes all of the engine CPP files in them, and it doesn't look like the engine actually is a separate like static library or anything like that. It looks like it's not a separate module at all, it's just all inside every single executable, which is obviously a weird architectural choice. Usually what we would do is all the common code for our engine in this case, especially since this is literally called a game engine, would be in a separate module, usually a static library, and then every single game project would really just be like this one file probably, which contains the entire game, and then everything else would just be in that static library. That keeps everything a whole lot cleaner, but even for something like this, it means that we don't have to rebuild the same exact files so many times. The end result is also identical, meaning that because it's a static library, all of that code does get compiled into our executable. So it's not like it's a separate DLL or anything like that that you might not want. It is still the same end result. And in fact, you even get all of the potential optimization that comes from building a static library rather than a dynamic library. However, it just keeps the actual project structure a whole lot cleaner. Now, obviously these files are not actually separate files. I say confidently without actually knowing the truth. No, they're not. So we have our repository, then we have source and engine. So all the engine files are in here. They're just simply included into every single game project, and then every single game project is just that specific game. So that is literally my first piece of advice. Separate out your core engine into its own static library and then just link that to all of your executables. So to run the game binary in either client server mode or peer-to-peer mode, and also as either the server or the client role, this is what we have to do. So we have some arguments here to pass in. Since we have to run both the client and the server, let's get that running for this homebound game. And furthermore, if we just try and execute it, we're not going to find any of the assets. So what we need to do is basically create a couple of shortcuts that provide this executable with everything it needs. So to do that, let's right click on this. And of course, create shortcut is not in these options. So we have to click show more options and then create shortcut. Let's call this one client. And if we right click properties on that, which also Alt Enter does, look at this. I turned up my scaling to 150% so that the UI would be bigger for you guys watching the video. But this very vital Windows properties window does not scale. So it's all blurry. We're in 2025, like, come on. So target is what it's actually going to run, and start in is the working directory. So you can see the start in is actually set to this current directory as you would expect, but we need the assets. So if we go back to the root of the repository and then source games, and we find that homebound game, that obviously has the assets directory in it. So let's just copy this path and then we'll just paste it in here. Now we also need the command line arguments. So we'll add them to the end here. This is our client. So we will add mode CS client server and role client, and then we'll hit OK. That should be the client taken care of. Let's copy and paste that shortcut, rename it to server. And then if we have a look at this, we'll just change the role to server. Look at me making a tutorial on someone else's game engine who had this pinned for 2025. Okay, so it makes sense to run the server first. So let's open up the server. We're listening on port 5555. Note that there's no like GUI, there's no window. So that's obviously good. And then now let's open up the client, and looks like it worked. Let's resize this. Oh, It's resizable, first of all. It doesn't really quite resize nicely, but props to you for having a resizable window, because that's something that I've seen so many projects sent to me not have. They're always like fixed. So let's put this over here, and then let's open up another instance of the client. And now, hopefully, yep, there I am. I'm this character. So let's move around here, and you can see it looks like networking is in fact working. Multiplayer is working. Oh, I died. I respawn. Okay, and then we got this character here. We got some enemies. There's the house. Oh. You reach the house, you just close the game. Nice. That's funny. There you go. That works. No crashes, no nothing. I mean, we don't know if it crashed or not because we don't have the debugger attached. And of course, it did just close the game when we got to the house, but pretty cool. So whilst we of course can run the server like this on Windows, since this is a game engine and presumably we would want to make more complex games that might actually have their own dedicated server, how does that usually work? Well, usually we'd be running on Linux and we wouldn't be running with any kind of GUI at all. For example, we might grab a VPS from Hostinger and then just deploy our server onto there. According to the README, we do in fact support Ubuntu, as you can see. The specific version it lists here is 24, so that's really good. Let's try and actually run this server on Linux on an actual VPS, and we'll see if that works. So first of all, we need a server, and for that we're going to use Hostinger, the sponsor of this video. Whether I'm building a website or I just need a VPS, Hostinger is my favorite web host on the internet. Their servers are extremely high quality, super fast with AMD EPYC processors and NVMe SSDs, but they're also super affordable, making them really great value. Hostinger's VPSs use KVM virtualization, ensuring separate resources for each VPS. This is super important for performance and stability. They give you full root access and enhanced security such as their Vanguard DDoS filtering. That, along with their beautiful dashboard and excellent documentation, make using Hostinger a fantastic experience. Let's head to hostinger.com/Cherno and then choose a VPS plan. The most popular one, as you can see, is KVM2. You can scale across this really easily, so if you need more resources, just change your plan. Because of that, I generally recommend starting with something with less resources unless you're sure you're going to need a beefy server. So let's just go ahead and choose KVM2, which is their most popular plan. The process here is super simple. You can choose how long you want the server for, and don't forget to use coupon code Cherno to get an additional 10% discount. Once you've got the server, it'll appear over here in your dashboard. Let's go ahead and set it up. So the first thing we'll need to do is actually pick a location for it. You can see that Hostinger actually provides us with actual latencies to like where we are. Usually when setting up a new server, I like to pick the location that's closest to the majority of the users of either the app or the website that I'm building, rather than necessarily closest to me. However, since we are just testing out a game engine here, it makes sense to pick the best latency for us. So let's go ahead and pick Indonesia. Now we need to pick an operating system for our server. There's a whole bunch, as you can see, to choose from, but since this game engine we're reviewing specifically lists Ubuntu, let's go ahead and pick that. And it did also mention Ubuntu 24, but either way, that's the LTS version, so let's go ahead and pick that. From here, we just need to set a root password, and then we are done. There's our final setup. Let's go ahead and click finish setup. That took like a minute. So now that this is done, let's go ahead and SSH into our server. And that's it, we're in. Go to hostinger.com/Cherno to sign up. That link will be in the description below. And don't forget to use code Cherno for an additional 10% discount. Huge thank you to Hostinger for sponsoring this video. How do we get this game engine and first of all, build it on Linux on this server and then run it as a server? So the first thing that's actually a little bit concerning to me here, in fact, a lot concerning to me, is that both the client and the server use the same executable. That's immediately incorrect. And the reason why that's incorrect is because you can see that the client has all of these dependencies, such as, you know, SDL2 and SDL2 image, which are to do with graphics and creating windows and, well, running the client. However, when we launch the server, no windows are created. We just have this console here and that's it. So then how is it that we just have this executable that obviously links all of these libraries? Because that's not going to work on a real server. The reason why is because SDL2 includes code to actually create a window, which on Linux is most likely going to use something like X11, a windowing system that simply is not going to exist here at all. Now, there are dummy versions of these libraries that we can use to make this stuff work, but that's not ideal. So in other words, we clearly need a version of this executable. I mean, it's not going to be exactly this executable, a version of this project that builds into an executable for Linux in this case that does not include anything that might not work on our server. Generally, this version of your game engine or game or application that does not require any windowing or rendering is called headless because it doesn't really have that I guess, head to interact with and see. I made a whole video on this headless thing a while ago. I'll have it linked up there. The first step generally to get this working is to trim all of the fat, trim all of the stuff that we don't actually need to run this in a server environment. So first of all, how do we even know what we are using that we shouldn't be? Is there a way to have a look at what it is we're using as far as dependencies go that we may not need? Yes, there is. My favorite way is an app called Dependencies. Now, for those of you who have been around for a while, and in fact, not even that long because I know about it, there's this legacy software called Dependency Walker, whose development stopped around 2006. This thing, I remember using this. I think I was introduced to this at like EA or something, so a while ago. And to be honest, it's great. I've actually been using it. I think last time I used it was last year, but there is this new thing here. I don't actually know how, it's not that new, but it's new to me. So I'll have this repository linked in the description below. You can just click this button here to download it. And once you have, we have the dependencies GUI.exe, which we can open, and then we can just grab our executable that we just built and drag it into here. Now, it will show us exactly what is being used, which is important. So if we have a look at this list of DLLs, most of them, all of these actually, are just operating system and compiler DLLs, right? So we have some Windows libraries as well as the actual C and C++ standard library. So these three up here are what we are interested in. And you can see that we have libzmq, which is that networking library that was used. And then of course we have SDL. Now, if we click on any of these, such as SDL2image.dll, then we can see what's actually being used. So from that DLL, we're only using a single function, image load. That's pretty straightforward. We don't need to be loading images in our headless build for our server. And then in the SDL2 library, you can see a lot of stuff is happening, from initialization to rendering, polling for events and stuff like that. Mostly just rendering, window creation stuff that you would expect tied to that. And then from the networking library, we're obviously doing socket and connection stuff, as you would expect, that we need since our server has to communicate. Using a tool such as this, I think, is a really good idea because it shows you exactly what it is you're using. If we had to go through all the code to figure out what we were using from all of these things, that would be a little bit annoying, as well as actually listing all of the DLLs that we link to in the first place, especially on an unfamiliar project, and especially if it happens to be a lot bigger than this. So this is a great way to just have a look at a glance at what you're dealing with. The more aggressive approach is just to be like, delete SDL, and then let's fix all the build errors. But this just gives us a look at what we're dealing with, as I mentioned. Now, that being said, SDL2 does actually have a headless build mode, like a dummy video driver build mode. I had a quick look, and if you just Google SDL2 dummy and look at the AI overview, which generally I don't recommend you do, but in this case, I don't know, I just couldn't find too much actual documentation, even though we did have some source code here. If the SDL video driver environment variable is set to dummy, then it's not actually going to create any windows. It's basically going to use like this null video implementation, which is definitely a good feature. It's definitely an important feature for frameworks such as SDL. However, it's still not really ideal. If I was making something a bit more serious, then I would definitely prefer to possibly just not even have SDL2 at all. The goal generally is to obviously have as little overhead as possible for your server, and running through all of this SDL stuff that, you know, is going to go to this like dummy video driver implementation, right? So it's not really going to do anything, but there is still obviously the overhead of linking in this library and going through this much larger framework that is completely unnecessary. But again, not a huge deal, and for a small like university project or a game, it's a really easy way to just build the server-side component, because you literally don't have to strip any code out. You don't have to have different, I guess, versions of your game. However, you are of course going to have to build SDL2 in that headless mode. Although, I don't know, maybe if CMake doesn't find any windowing systems installed because you're trying to build it on a server like we're about to do, it might just automatically set that. But again, we're going to find out in a minute, because I'm going to try and build this game engine on the hosting a server that we just set up. When it comes to getting this project onto the server, you've got a few different things you can do. Obviously, the most straightforward way would probably be to just pull it from Git. However, I'm just going to keep things a little bit more simple because I don't have Git installed even on this new server. And I'm literally just going to go ahead and transfer like all of this stuff to the server. Now, my favorite way to work with servers in this context is by using Visual Studio Code. There is a great extension for VS Code called Remote SSH. Go ahead and install that. And then if you hit F1, you can add a new SSH host host and then just connect to it. And you'll be able to basically get yourself into this view here where we have an empty folder. If we want to go ahead and spawn a terminal, we can create a new terminal. And the point of this obviously is that we can just open up files as you're about to see in VS Code, edit them, Control S, run them here, rebuild our project as if we were doing it locally. So what I'm going to do is just grab all of this stuff. We obviously don't need build VS Code or GitHub, and just drag it into the game engine directory that I just made. And then in a little bit, we should see all of our files over here. So let's go ahead and go into that directory. I'll make a new directory called build like we did on Windows, and then I'll just call cmake ... Now, as you saw, this was a completely fresh new server. So the things that I had to install were cmake and clang. And that, I think that's literally it. I cut that out of the video because I don't think you guys need to see that. So with cmake installed, obviously, let's go cmake ... and let's see if this compiles as expected without SDL2 being able to use the windowing systems. By the way, obviously we're not compiling at this stage, we're just generating the make files, but still we'll see if this works. Okay, I mean, that seemed to work. Let's have a look at the build directory. So yeah, we've got a make file. Okay, so let's just try and run make, and we're gonna compile. Oh, by the way, quick little thing. You should probably not just call make like that. If you add a -J and say 8 for 8 cores, 8 threads, it will compile much faster, as you can see. Okay, well, that, I mean, somewhat surprisingly to me, to be honest, sorry guys, built successfully. So looks like the executables would be inside this subdirectory. Let's have a look at this. There it is. So let's go ahead and try and run it. Now, obviously we want to run the server, so we'll have to do this. Paste that in and enter. It runs. Might be a little bit too early to celebrate though, because, well, we haven't connected to it. So let's try and connect to it. If we go back to our client build directory, which is over here, we have the shortcut that we made. According to the README, you can use this -- server IP on clients. See how good it is to have a README file, by the way? People take note. I'm probably like gonna stop reviewing projects without a README in the future. So if I paste in this IP address of the actual server, let's hit OK, and let's try and connect. Okay, check it out, we're in. Why is this running at like, what is that, like 2 to 3 frames per second? This had so much potential. I actually thought this would be great. Now, I didn't really expect this to run amazingly, but this is really, really bad. This is way worse than, you know, just like what would happen if you didn't do client-side prediction or anything like that. It seems like this was totally fine when it was on localhost, but then as soon as we have a remote server with some kind of latency introduced, this obviously just entirely falls apart. Let me try and start up another client and see like if that works. So I'm up here. I mean, I'm not even in the game, I think. This guy's still here. And then, oh, there we go, I've appeared. So it's like a few seconds delayed. Obviously the ping to the server is nowhere near that bad. Okay, so unfortunately, that's the way it is. Oh, also check this out. Look at how laggy this is. I actually think this whole game is somehow running at low frame rate, because even like pressing the close button was delayed. Okay, let's investigate this. The server itself seems to have run fine. It did great, I guess. I'm just going to take a deeper look at the client. So engine.cpp seems to be where most of the stuff happens. We have the main executable, I guess. This will have the main function in it, which just uses the engine as a singleton seemingly. It sets up everything here and then eventually starts it. Depending on what kind of mode we're in, it will either, we're doing client server, so we'll either start the server, so this is what our servers are going to be doing, or in our case being the client here on Windows, it's going to start the client. Here's our main loop. Okay, I've already got some ideas as to why this may be an issue. What I'm interested in is how we actually deal with networking. So it literally does look like most of the stuff is all in this one file. It's immediately a little bit hard for me to make sense of this because we're both the client and the server within one file, within one executable. So if you have a look at the header, I'm sure we'll see, yeah, I mean, look at this. We have the server broadcast socket. We have a client update socket. We have the client threads, which I'm guessing the server has like a thread per client or something in this case. We've got init client server server, we've got init client, we've got peer-to-peer host and peer. Like this is really, really messy. Like this is, I generally don't mind having like large files. It's fine to combine even many classes into a single file if that makes sense, but this is one of those cases where it really doesn't make sense, because not only is a server and a client different concepts, they literally should be different applications. They should be different executables. So having them all mixed up like this makes this like just a complete nightmare. Because if if we look at the broadcast, like I'm typing in broadcast here and there's so much stuff, so many functions come up. So we've got like client receive broadcast thread, which I'm guessing the client uses to receive messages like from the server. One thing I've noticed as well is there seems to be Tracy being used here. Tracy is like a profiling tool. So immediately my strategy to understand this, because I'm honestly feeling a little bit overwhelmed, which isn't something I've said often in these code reviews, but this is like 4 applications in one file. This is like the peer-to-peer and client server architectures, host and client, server and client, everything just in one. So if I launch the appropriate version of Tracy, which I'll leave a link to Tracy, by the way, in the description below. I need to add the IP address as well. Okay, that's done. Let's go ahead and run this. There we go. If I go back to Tracy, then here is our client, which is pretty cool. By the way, one quick little thing about this particular project. Profiling is hidden behind this ifdef, so you need to have profile defined, otherwise it will just do nothing, which is good. That's correct, because you don't want profiling, you don't want this Tracy stuff enabled for your actual distribution builds. So over here in the CMake, I found that if profile is set to on specifically, then it's actually going to link Tracy, and obviously define as well. So that's one thing I had to do to actually get this to work. But anyway, you can see that it's working here, and our frame rate is, well, it's terrible. It's seemingly around 400 or so milliseconds per frame, which is fun. But importantly, if we just pause this, you can see where that time is being spent, right? So as someone who doesn't know this project very well, this is obviously a very useful tool, but also for your projects. When software gets more and more complicated, even if it's something that you yourself have been writing and therefore it almost seems like you should know everything, that's not how it works, unfortunately. Things scale up, things get very complicated. So even throughout your own code, using something like this can really help you understand what your application is doing, even if you're not using this specifically for profiling and like performance optimization or seeing where all the time goes within a frame. It's actually really useful to just have a look at what's going on, because, for example, aside from telling me that this is the specific function that I should be looking at because it takes an absurd amount of time, a third of a second, it also tells me that there are exactly 2 threads that are persistently running here. We've got the main thread, and then we've got this client receive broadcast thread. Now, I should also say that Tracy requires you to actually define your threads. You can see there's like a Tracy set thread name. So if the author of this game engine didn't actually specify the threads, then I guess we technically wouldn't see them here. But anyway, we'll give them the benefit of the doubt and assume that they've labeled all their threads. So we have the main thread and we have the client receive broadcast thread. So first of all, look at this. There's a client send update that's happening on the main thread. Not really something I would do ever, but the fact that the actual client send update, which happens every single frame, takes 300 milliseconds, almost definitely tells me that it is specifically, very specifically waiting for a response from the server before it even moves on, because there's no way that sending takes this long. When you are making a multiplayer game, especially a real-time multiplayer game like this one, you generally don't care about whether or not like your packet of data actually reached the server. Like you're not waiting for any kind of acknowledgement from the server or any kind of response from the server, because this is like a real-time game. And since you are sending so many updates as to like what you're doing, what the player's doing, what your position is, all of that stuff, pretty much every frame, I mean, usually you'd decouple it from actual frame rate and stuff like that. You have a network thread running at a fixed sort of interval, but still, you know, you're sending like, could be 30, could be 20, could be 60 updates per second. Clearly the server doesn't actually need to receive and acknowledge every single update that it receives from you, because if it misses one, then the next one will actually be even more up to date, which is even better. So just by looking at this, what I suspect is happening is there has to be some sort of like server client communication that's blocking this thread, because no way does sending data take anywhere near that much time unless you have a server that has a decent amount of latency on it. Because remember, also locally, this was instant, right? So it's clearly not like the CPU load. Not that we ever thought it was, I don't think. I don't know, maybe someone watching this was like, packing the buffer for all of those entities probably does take a third of a second. No. Since this was running fine locally, it doesn't take a detective to figure out that maybe it's something to do with the server latency. But again, the server being far away does not equate to your game running at 3 frames per second, or at least it shouldn't. So that was enlightening. Let's have a look at this CS client send update, which seems to be in our engine. And we've got a little try catch block. So what are we doing over here? We're basically just getting this client player. We've got the player position, the name, and then here it looks like we have some sort of update. So we're encoding the message and then we do client update send. But then after sending this update, it looks like we are waiting for a response, server ACK, which I'm assuming stands for acknowledgement. So we're literally waiting for an acknowledgement back from the server after sending this, and critically, this is on the main thread, which is kind of bizarre. So generally speaking, you don't really want to do any kind of network operations on your main thread. However, the reason why this is running so slowly can't just be because we're sending data from the main thread, because that's usually really quick. It's because we're waiting for some sort of acknowledgement. So it looks like this is almost like a TCP style connection where, I mean, how do we set up this socket? I'm not a big ZMQ like person, but you can see that we have various different socket types. There's quite a good page which I have flipped through, which talks about like various patterns that they have for communication between sockets and everything. But what I've basically sussed out from that is that this is like a TCP style socket. Pub and sub is for broadcast style patterns, and push and pull is kind of a more UDP style thing. So you can see like the server broadcast socket, for example, has this sub here, which I'm guessing we're subscribing to this broadcast channel effectively. And then client update should probably not be this, but if this is the actual client update, then it should be a push, I imagine. And then server side, we'd probably want it to be like a pull. And then when it comes to actually sending the data, there are a few different send flags over here, namely one called don't wait, which means don't block this thread, don't wait for anything, just send it. So if we get rid of the acknowledgement and we send it without waiting, our server is still running. I'm assuming this won't quite work because again, we need that pull from the server, but oh, look at this. We're actually, I mean, the server is, the server is kind of either not coping or something, but you can see we can actually kind of play the game more or less properly. This is, I'm sure, happening locally, whereas these entities must be remote because they're kind of lagging a bit. Is our server saying anything? No, our server seems pretty happy. We're not getting any exceptions. Anyway, I wouldn't quite call this fixed or anything. However, this does seem to be more along the lines of something you would expect. Again, we are still doing this on the main thread, which is incorrect, but at least we're not, you know, blocking the actual main thread anymore whilst waiting for that response, and we're able to actually run our application smoothly. The way that I would probably set this up more realistically and how I would move it off of this main thread is by having a separate network thread, which we seem to already have because we have this like client receive broadcast thread, which is a persistently running thread over here. Ooh. Okay, one thing I just thought of that I noticed, which is probably terrible, is I'm not seeing any kind of sleeping going on here or any kind of timing. Like this is just a while loop that seems to just run 100% CPU usage. Let's have a look at the server as well, because that actually is quite concerning. If I have a look at this engine CPP file here, so we have this CS server client thread, which is probably the thread that the server creates for a given client. And then this just has a while loop. yeah, with no sleeping or anything. So how fast is this running? Let's go ahead and just see quickly. I'm just gonna make a static uint. We'll call it I. We'll set it to 0. We'll do a printf. Sure, we'll accept this. I don't really care about this though. Let's just do server update. We'll run make. See, this is another reason why having the project set up like this is really annoying. I'm running make and I've modified one file, right? This engine.cpp file. But because it's not built as a static library and it's just manually included in every single executable, it effectively has to compile it all of these times for each of the game projects. Now, obviously I could just build a single target, but it would still be much faster to build and easier to deal with if it was just a static library. All right, let's get back to our other terminal over here and we will rerun this and have a look at what it prints. So obviously we have to connect first. So let's go ahead and connect, and then Let's go back here. So strangely, I mean, it printed once and then it just stopped. So are we just paused over here? Like, is it trying to receive or is it trying to send? And it's blocking it? I mean, I think it's sending data because these entities are moving on the client. One thing I might do as well, maybe the broadcast is what's moving that. I think maybe it's failing to receive because remember how we made it a push? So we might have to change this to be pull. So up here, when we create the actual socket, let's make it a pull. And then, I don't know, I'm assuming we probably shouldn't wait for a result. I don't know, let's try this. Let's just rebuild it quickly. Okay, and if we run it again, launch our client. Oh, okay. Look at these numbers, guys. And that's probably honestly why there's so many issues, because obviously we're just completely overwhelming the socket. Now, obviously this wasn't an issue before because we were doing this kind of TCP connection style where we were literally waiting for the server to acknowledge receiving something from the client, and that itself took so long that overwhelming the socket was not an issue at all because the latency of the actual connection, as well as the fact that since we're waiting for an acknowledgement, we're waiting for a response, we're doing a round trip to the server and back, that latency basically ensured that we weren't sending too much. But now we're kind of freeing ourselves, and obviously it's running way too quickly. So in this case, we would have to add some kind of sleep or some kind of timing functionality here to make sure that we actually send updates at a fixed rate rather than as quickly as we can. And it's not even just sending those updates, but I mean, in this case, it looks like we're trying to receive from the socket, but then also send in this case, which I guess the reply was not something we needed to do. Probably why we're actually getting this error is because we're trying to, I guess, maybe send from a pull socket, which is wrong. And again, it's definitely easy to make that work locally where there is basically no latency. I mean, there is no latency, but you can see that as soon as we scale this up and we try it in a real scenario where we have a server with latency, we run into issues. So in summary, whilst I could maybe try and fix this, like it's honestly, it's such a mess that it doesn't really make me want to, but the main takeaways are basically, number one, don't do networking on the main thread, like ever. And number two, make sure that you have a distinction, I guess, between data that you just want the most up-to-date version of versus data that you reliably need to actually communicate between the client and the server. So for example, a player moving, the position as it's changing, that should be totally fine to send via UDP basically, where you don't need to wait for a response or make sure that it's received, and if it's not, like send it again. Like no, because by then you're somewhere else anyway. You can just send that, and if you lose some packets, no big deal. Make sure you have a distinction between that kind of data and other things like, I don't know, maybe like the player died or a chat message was sent. Stuff that like you do actually need to receive properly, that can be TCP, that can be done via that, like, you know, socket type rec kind of thing. But other game data such as like the player positions do really need to be sent in a much quicker and more efficient way. Let me know what you guys thought of this project in the comment section below. I actually thought it was, I mean, it worked on Windows. It wasn't too bad. The actual code itself, I know I didn't really comment much on it. I mean, you know, using this keyword unnecessarily is a little bit annoying, but aside from that, I think it's probably okay. And the fact that this again does work and has so many example games shows that it is like a pretty decent and serious project. However, as far as networking and multiplayer architecture goes, I think that there's, yeah, like a lot of room for improvement here. If you guys want me to review your code, then send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. If you need a server to test out your networking applications in, then hosting.com/Cherno, that link will be in the description below, and use coupon code Cherno for a 10% discount. Thank you all for watching. I'll see you next time. Goodbye.